Let's get started with URM data acquisition guidance. First, we begin with clicking the URM button. This takes us to the URM interface, where we can adjust imaging parameters for contrast-enhanced imaging aimed for URM. These parameters include frequency and URM frame rate, which should be optimized based on the targeted organ. Additional settings such as sharpness, dynamic range, and the edge enhancement can also be adjusted here. This section allows us for modification of acoustic power for contrast imaging. We can also select the type of microbubbles we used. Once all parameters are set, we instruct the assistant to inject the contrast agent. Simultaneously, we press the Start button to initiate ultra frame rate UFR CBR imaging. As the contrast agent begins to wash in the lesion, we proceed with the first URM data acquisition. During the acquisition process, the patient should hold their breath for approximately 10 seconds to ensure a stable image capture. After the first acquisition, the patient is asked to adjust their breathing before holding again for a second 10-second scan. Finally, a third data acquisition is performed under the same conditions. These three URM acquisitions better correspond to different phases: the arterial phase, portal venous phase, and delayed phase. Next, we move on to URM data analysis. We begin by selecting the URM data stored in the clipboard. The system automatically generates an ROI box. These ROI boxes can be adjusted by size and position based on the lesions and the objective of our analysis. If we aim to analyze the microvascular distribution within the lesion, then we place the ROI box inside the lesion. If we want to compare the lesion's microcirculation with the normal tissue, we then expand the ROI box to include the surrounding tissues. Once the ROI box is set, we need to perform motion composition for the URM data based on the unwanted movement during acquisition. We can use this button to adjust motion composition. Here, we also have a V-speckle parameter for controlling the amount of image information retrieved. A higher value means a higher speckle threshold, resulting in smoother information acquisition. If we want to obtain richer, more detailed imaging results, we should lower the V-speckle value. Once these two parameters are adjusted, we click Analyze, and the system will automatically perform URM data analysis imaging. Once we obtain the processed URM data, the touchscreen will display URM post-processing parameter adjustment interface. The first setting is display format, in which we can choose display URM data only or URM data along with background tissue. Besides, we have split screen display with left-right or top-bottom mode. By default, the setting is left-right split screen mode. Next, we have these different URM imaging modes, including URM density map, URM direction map, URM velocity map, and the URM angle imaging. For URM imaging, we use this button to choose if we filter background tissue or keep the background tissue visible. Additionally, when viewing density imaging, we can utilize different color maps to present various color representations. Below, we have URM post-processing parameters. The first is the URM resolution. We can click to adjust different levels to reach various microvascular imaging details. The second is smooth. When acquiring URM data, we can adjust to get smoother blood vessel edges or sharper, finer vascular edges. This is the URM vascular scale. A higher level brings a more prominent blood vessel shape. Here is the density and contrast parameters. We click this to adjust the image contrast. So once these parameters have been adjusted, we can save data from different URM imaging modes. Additionally, by using the Trace button, we highlight specific areas of interest we wanted to save and store the corresponding URM data. Of course, we can always select Return if we don't want to save it. Here is a dynamic microcirculation feature as well, a real-time visualization of microbubble perfusion. Press this button, we can generate a dynamic URM video. When we enter the URM video imaging mode, we can adjust parameters such as demonstrated microbubble size, video type, means adjustment of presentation methods for different types of microbubble perfusion. The overall playback speed is here. We can analyze the wash-in process at an ultra-slow speed, or play it at a normal speed. We can also choose to show or hide background tissue here. After adjusting these parameters, the last step is to store the dynamic URM data. Next, let's proceed to URM quantitative analysis. First, enter the quantitative analysis interface. Then select vascular density and velocity analysis. We then define a region of interest, and the system will automatically generate density analysis and vascular distribution, the vascular complexity, and also the vascular tortuosity values. Additionally, we can also zoom into specific regions of interest we wanted to see and adjust different scaling ratios and perform microvascular density fit analysis. This provides a detailed inner diameter assessment of the vascular structure in a selected region, which allows us to obtain a visual representation of the URM data.